Okay, this is the notes for 7-2, solving quadratic equations with imaginary solutions. Notice on number 1, we have a negative underneath the radical, the square root sign. There is absolutely, if we put that in our calculator and hit enter, it's going to tell us error. There is nothing that we can do to multiply times itself to get -5. It would have to always be a positive times a negative number. So a square root of a negative number does not exist. So we use what we call an imaginary number, the symbol I, okay, to be able to take the negative out. And I equates to the same thing as the square root of -1. Okay, so on the first one, in order to take out the negative, I just bring out, let me zoom in so it makes it a little easier. Okay, so I'm going to bring out the negative as an I. Okay, and I can take that negative off. Now I can work square root of 5. Now there is no perfect square for square root of 5, so there's no number other than 1 times itself to get 5. So I just put it right back underneath the radical. So it's I square root of 5. Okay, now number 2. All right, on number 2, we have negative square root of 25. So on this guy, I see that there's a negative, so I want to immediately bring out an I and get rid of my negative. 25 breaks down to 5 times 5. So whenever I have a pair, remember before Christmas we did this, we treat it like a pair of shoes. If I have a pair, I can bring it out as a single pair of shoes. So 5i. There is nothing left to put back underneath the radical. Okay, number 3. I see there's a negative, so I'm going to go ahead and bring out an I. Take off the negative. 45 breaks down to 9 times 5. 9 breaks down to 3 times 3. 5 will only break down to 5 times 1, so I know it's prime. I can't go any further. I do have a pair of 3s, so I bring out that pair of 3s as one single pair of shoes. And then there's a 5. Treat that like there's a shoe without a missing pair, so we put it back in the box. We're going to put it back underneath the radical, underneath the square root sign. Okay, now on the next one, negative square root of, or square root of negative 180. So I take out the negative as an I. I break the 180 down. There's multiple ways to break 180 down. There's lots of things that'll multiply to get that. So I'm just going to pick what a lot of the kids picked today, which was 2 times 45. I'm sorry. 2 times 90. Okay, now 90 breaks down to 2 times 45. 45 breaks down to 5 times 9. 9 breaks down to 3 times 3. So now I start circling my pairs because that's as far as any of them will go. There's a pair of 2s. I bring it out. And a pair of 3s. So I had 2 different pairs to bring out, so I have to multiply them back together. There was a 5 left over, so it has to go back in the box. So 2 times 3 is 6i square root of 5. Okay, moving on to number 4. Number 5. On number 5, it's an equation, and it wants us to solve. The equation has to be an ABC form, meaning that my x squareds have to go first, then my x's, then my regular numbers, then equals 0. Okay, it has to be in that order in order for us to be able to do this. First thing you'd want to do is put 5x squared plus 6x plus 5 into your calculator, graph it, take a look at it, and that would yield a picture that looks like this. That means there are no roots. It never touched our x-axis. In order for there to be roots, it has to cross the x-axis. So we know it's an imaginary number. So we use the quadratic formula, which is negative b plus or minus square root of b, close parentheses, squared, minus 4, parentheses, a, c, all over 2a. Notice I put all of the variables in parentheses because that's how we want to put them in our calculator. Now we label out our A, B, and C in alphabetical order. A, B, C, they are x squareds are my A's, my x's are my B's, and the regular number is my C's. So my x squared value is 5. My B value is 6. And my C value is 5. I'm going to plug them back into that formula. Negative B, which is 6, plus or minus square root of B squared, so that's 6 squared, minus 4 times A, which is 5, times C, which is 5, all over 2 times A, which is 5. Okay, now when I do this, because I know it's imaginary, if I put that into my calculator and hit enter, it's going to tell me error. And that's because underneath, so I'm going to highlight here, underneath the square root, that will come out to a negative number. So I just want to put that in my calculator, not the square root. Don't put the square root, just the parentheses, 6, close it, squared, negative 4 times 5 times 5. Hit enter, and then you're going to replace that with the number that you get when you hit enter. Okay, and in this case, that number is a negative 64. So going back, we have negative, let me get back to black. So I have negative 6 plus or minus square root of negative 64. That's what all that came out to when I multiplied it. Over 2 times 5 is 10. Okay, so I see there's a negative underneath, so I want to move it to the side just like we did on 1 through 4. And the negative has to come out as an I. And then I can get rid of my negative. Break down 64. 64 can break down a multitude of ways, but most of the kids said, hey, 8 times 8, and we already have a pair. So bring out that pair as 8i. So I'm going to replace the square root of negative 64 with 8i. So I have negative 6 plus or minus 8i, because I just replaced that square root of negative 64, over 10. We look at all those, and they're all even numbers, so I know I can reduce for the last step. So last step, I'm going to reduce them all by 2. So negative 6 reduced by 2, so divide by 2 is negative 3, plus or minus 8 divided by 2 is 4i, all over 10 divided by 2 is 5. Okay, so that's my answer. That's my roots. To the next one. I want to put these guys, they're not in ABC order. See, my 5x squared, or my 5x and a negative 3 are on the wrong side. I have to move them across. Okay, so first thing I want to do is get them in the correct order, always. So x squared goes first, it's already first. 3x squared, it's on the right side, or the left side, which is where I want it. Moving the 5x across makes it a negative 5x. Move the negative 3 across, makes it a positive 3. Now equals 0. So now I have my A, B, and C. A, B, C. A is 3, B is negative 5, and C would be 3. Put it into my formula. Minus B, which is minus 5, plus or minus square root of B squared, which is negative 5 squared, minus 4 times A, which is 3, times C, which is 3, all over 2 times A, which is 3. Okay, I take only what's underneath the square root. So only this stuff here, put it into my calculator, hit enter and replace that. So when I do that, it comes up with a negative 11. Okay, so I have negative and a negative make a positive 5, plus or minus, replacing everything underneath with a negative 11, over 2 times 3 is 6. So I see I have a negative there, so I move it to the side. And the negative comes out as an I. Now 11 doesn't break down because it's a prime number. It's just 1 times 11. So I put it right back underneath. And I'm going to replace that with I square root of 11. So I have 5 plus or minus I square root of 11 all over 6. That does not reduce anymore, so that's my final answer. Moving on to number 7. It is in ABC order already. Okay, my x squareds are first, then my x's, then my regular numbers, then equals 0. So A, B, C. A is 1. B is 4. C is 16. Put them into my formula. Minus B, which is 4, plus or minus square root of B squared. So that's that is 4 squared minus 4 times A, which is 1, times C, which is 16, all over 2 times A, which is 1. Again, taking only what's underneath, putting that into my calculator, and hitting enter. And when I do that, it gives me negative 48. So I have negative 4 plus or minus square root. Replacement is negative 48 over 2. Take the square root of negative 48, and I've got to break it down. I see the negative first, so I take it out as an I. 48 breaks down multitude of ways. You can pick any of those. Let's go 4 times 12. 4 breaks down to 2 times 2. 12 breaks down to, let's go 2 times 6. 6 breaks down to 2 times 3. Circle my pairs. There's a pair of 2s. Bring it out. Another pair of 2s. Bring it out. Oh, let me clean that up. Okay. All right, trying to clean up so you guys can see a little better what I got going on here. Okay, so I had a negative 48, brought it out, okay, as an I. Then I broke these guys down. Oh, broke these guys down. Circled my pairs, brought them out, multiplied them back together. And then I had a 3 left over. So that 3 goes back in the box. So 2 times 2 is 4. So this gives me 4i square root of 3. Okay, I'm going to replace the negative 48 with that. So I've got negative 4 plus or minus 4i square root of 3 all over 2. Now I can reduce this. Don't pay attention to the square root of 3. I can't touch that. Anything underneath the radical I can't touch when I'm reducing, but everything outside I can. So I see negative 4, 4 and 2. I know 2 goes into all of those. So negative 4 divided by 2 would be negative 2 plus or minus. 4 divided by 2 is 2i square root of 3. And 2 divided by 2 is 1. I can put it back there, but I don't have to because anything over 1 is itself. So if you just want to circle that right there as your answer and not worry about the other, you can. Okay, so you can take that 1 off. All right. All right, the assignment for this one is A7-2. We did numbers 1, 3, 5, 6, 7, 10, and 12. This concludes the notes for 7-2.